Sometimes the most incredible stories of innovation don't come from some shiny, brand new invention. Nope, they come from finding a clever new use for something old. Today, we're going to dive into a story that's personal, it's powerful, and it's deeply scientific. It's from the very dawn of the genomic age, about a moment when a desperate need for discovery ran headfirst into this brick wall of budget and technology. And it all kicks off with one single audacious idea.
Yeah, you heard that right. I know, it's a statement that sounds completely impossible, but it's the absolute heart of our story today. It's about how these massive computers, originally built for the monumental task of the U.S. Census, were ingeniously repurposed to unlock the secrets hidden deep inside our DNA.
So let's start with that impossible premise. We're going to go back to the early 1990s, a time when a state research institute and the world's library of genetic code were about to collide in this amazing story of ingenuity.
So what was this roadblock they were up against? Well, back in the early 90s, genetic data was just exploding. But for this small, vital, state-run institute, all of that incredible information was basically trapped behind a massive technological and financial barrier.
Okay, so first, let's meet the scientists at the heart of this, the Institute for Basic Research, or IBR. This wasn't just any research facility. Its mission was, and still is, to understand the fundamental genetic causes of developmental disabilities. We're talking about conditions like autism and Fragile X syndrome, which is a leading cause of inherited intellectual disability. Their work had the potential to change countless lives, to finally provide answers where there were only questions.
And to get those answers, they desperately needed access to this, GenBank. You can think of it as the ultimate genetic library, managed by the NIH. It's this massive public database where scientists from all over the world submit the genetic sequences they discover. So if you wanted to see if a patient's DNA had a unique mutation, the very key to their condition, GenBank was the place you had to look. It was, and is, the encyclopedia of humanity's code.
And that brings us right to the central problem. IBR had brilliant scientists. They had urgent, life-changing research questions. They had all the human expertise you could ask for. But what they didn't have was the money for a supercomputer. So they're standing at the base of this mountain of data in GenBank with absolutely no way to climb it. Just imagine knowing the answers you need are in a library, but you don't have the key to the front door.
So that was the critical question, right? How could a state-funded institute, which, let's be honest, wasn't a priority for big tech investment, possibly find the horsepower to sift through a global database? The answer wasn't about getting new funding. It was about looking at old technology in a completely new way.
They had to get really, really creative. And the solution came from an entirely different arm of the government, from a machine built for a completely different, though equally massive, data problem.
So how in the world did they find a research engine inside a federal counting machine? Well, this is where a technologist at IBR, a guy named Mr. Ed, hatched this absolutely brilliant plan. He reached out to some federal contacts with this audacious proposal. He wanted to acquire the decommissioned hardware from the 1980 U.S. Census.
The timing here is just incredible. A decade after these powerful machines were used to count every single person in America, the federal government basically considered them obsolete junk. But for IBR, back in 1990, they were a lifeline. The hardware was acquired and repurposed, just as major policy changes were about to make their research more vital than ever before.
Okay, so the machines are in place. And this is where the story pivots from a clever tech solution to real, actual scientific breakthroughs. This old hardware was about to unlock the genome. So here's how this new workflow actually operated. First, they loaded the entire GenBank database onto the repurposed census machines. Then, a researcher could take a DNA sample from a patient and compare it against that huge global library. The computer would just churn and churn through the data, hunting for those tiny variations or mutations that could be the cause of a condition. And this part is so important. When they found something new, they submitted it right back to GenBank, creating this amazing, virtuous cycle of discovery for the whole scientific community.
And get this, right as the system was coming online, the world outside the lab was changing dramatically. The passage of the Americans with Disabilities Act and new Medicaid policies shifted the focus from big institutions to community-based care and support. This meant IBR's mission also had to shift. They needed better diagnostic and analytical tools to understand people living in real-world settings, which made their new genetic research capabilities absolutely essential.
So you see, this ingenious hack wasn't just some temporary fix. It was a bridge to the future. Let's take a look at the lasting legacy of this project.
which really transformed a single act of resourcefulness into a global revolution. To really understand the scale of what's happened since, just look at this. Back in the early 90s, when IBR was getting started, GenBank held thousands of genetic sequences, and that was a big deal, but it was manageable. Today, that number has exploded into the hundreds of millions. It's a number that's almost hard to wrap your head around. The very same database that was once loaded onto old Census hardware has grown exponentially, becoming an absolute cornerstone of modern biology.
And what does that mean in practice, in the real world? Well, it means GenBank is used to track emerging viruses like COVID-19 in real time, letting us watch it mutate from country to country. It's how scientists pinpoint the causes of incredibly rare diseases like Ogden syndrome, which affects only a handful of families worldwide. It's the raw data that fuels AI-driven discoveries today. That same database, once analyzed by census machines, is now completely fundamental to modern medicine.
So when you boil it all down, that's really the core of the story. A creative solution born out of pure necessity didn't just solve a local budget problem. It bridged a crucial gap, allowing vital research to surge forward when it otherwise would have stalled. And in doing so, it pushed our collective understanding of genetics forward.
And it leaves us with a pretty fascinating question to think about, doesn't it? This was a story of turning a counting machine into a research engine. It really makes you wonder what powerful tools are sitting around us right now, maybe seen as obsolete, just waiting for a new purpose. What impossible problems could we solve if we just looked at the technology we already have with fresh eyes?